Today we're going to look at the first half of Chapter 1, Section 6. We're still talking about angles, and we're going to look at three basic terms regarding angles today. The three terms are complementary, supplementary, and adjacent. I'm going to start with adjacent angles, and then we'll talk about complementary and supplementary. So starting kind of towards the bottom of the page here, adjacent angles. Adjacent angles are simply angles that share the same vertex, that share a common side, and do not overlap each other. Angles 5 and 6 here are a great picture of adjacent angles. Another picture of adjacent angles, I could do it pretty easily. Angles 1 and 2 here are adjacent angles. So not very difficult to draw adjacent angles. We do need to be a little careful with adjacent angles. If I put some points on here, A, B, C, and we'll call this P. Angle APB and angle APC, it's APC, are non-adjacent. And the reason is, if I look at this, APB is right here, APC is right here. They do share the same vertex. They do share a side, PA, but one is inside the other. APB is inside of APC. So therefore, non-adjacent angles. So that not overlapping thing does come into play sometimes. So again, they have to share the same vertex, share a side, and not be overlapping to be adjacent. The other two words are very similar, complementary and supplementary. Complementary angles are simply two angles that add up to 90 degrees. They may be adjacent. They may not be adjacent. They could be in completely different planes. One could be on your desk right now. The other one could be on the moon. If the two angles add up to 90 degrees, they're considered complementary. Complementary has nothing to do with the traditional definition of complement, which is telling you that your hair looks nice today or that someone likes your shoes. Nothing to do with that type of complement at all. It's a technical term that we use here to describe two angles for which there's, for which there's the sum of their measures is 90 degrees. So two angles, specifically two, not three, not four, just two. It's a complementary pair of angles, and the angle measures add up to 90 degrees. That makes them complementary. Supplementary is the same idea. It's just that this time the sum is 180 instead of 90. And again, 90 and 180 are pretty important angle measures. 90 is a right angle, 180 is a straight angle or a line. So pretty important ideas. So we have special names to describe angles that add up to that. Again, with supplementary, it has to be just two angles. Can't be three angles, can't be four. Nope, just two. It's a supplementary pair of angles. That's what it is. So let's take a look at this a little bit. Here I've got a picture. I've got several angles here. Notice the 127 degrees, 37 degrees, 53 degrees. Those are the measures of the angles. It's not angle 127 or angle 37. The degree sign there tells us that's an angle measure, not a name of the angle. So it says name a pair of complementary angles, a pair of supplementary, and a pair of adjacent. Well, it's pretty much set up to work pretty nicely for us here. Complementary angles. So my complementary pair are angle, two that add up to 90. Well, clearly CAD is out of the running for us. That's already over 90. So CAB is 37. And 37 plus what is 90? That'd be 37 plus 53, so that would be angle RST. Supplementary. My supplementary pair. Again, be careful here. It isn't BAC and CAD, the two that go together here. They aren't making a straight line. That's an obtuse angle, not a straight one. So it's angle CAD and angle RST. because 127 plus 53 adds up to 180. The adjacent pair here pretty clearly are angle CAD and angle CAB. And notice again, every time I name the angles, I use the angle symbol. That's important. You don't use a symbol, you might be naming a plane, you might be naming a triangle. I don't know, without the right symbol, I don't know what you're talking about. So make sure you're using that angle symbol. Here we go. Angle 1 is a complement of angle 2, and the measure of angle 1 is 62. Find the measure of angle 2. Well, what does it mean it's a complement? Complement means add up to 90. Please be careful with this definition. A lot of people say, what does complement mean? Oh, complement means 90. No, complement doesn't mean the angles are 90. Complement means the angles add up to 90. We tend to be very, very lazy in the way that we speak about things sometimes, so we try to take that shortcut. Complement means 90. No, that's technically incorrect. Complement means add up to 90. So if measure angle 1 is 62, we're saying 62 plus what equals 90. Pretty simple algebra equation. Probably can solve this in our head. X equals 28. And we're talking about a degree measure, so we should add our units. Angle 3 is supplement to angle 4. Angle 4 is 47. Find the measure of angle 3. Again, supplement means that 47 degrees plus something is 180 degrees. So if I subtract the 47 from both sides, I get 133 degrees. Okay? And if I really want to express this, I should say the measure of angle 3 is 133 degrees. Just like up here, I should have said measure angle 1 equals 28 degrees. Make sure we state our answers saying exactly what we want them to say. Basically the same idea on this page. These are good ones for you to go ahead and work on in your notebook. In fact, I'd like to see them completed in your notes. They're fairly straightforward. The only one I really want to look at as a group here is number 2. It asks, are angle KGH and angle LKG adjacent angles? And sometimes we can tell just by looking, sometimes we can't, but the easiest thing to do is to sketch them. And again, we're referring to the picture here. So angle KGH, that's that angle, and LKG, that's that angle. Are they adjacent angles? Well, they certainly seem to have a side in common, but do they have the same vertex? And the answer is no. Vertex here is at K, vertex here is at G. The very first qualification for adjacent angles is they have to have the same angle, or same vertex. So no, not same vertex. Then it asks FGK and FGH. Well, let's see. FGK and FGH. Are those adjacent? Well, they do have the same vertex. They do share a side, but they overlap. So no, angles overlap. That might be a decent explanation. If you said the angles share common interior points, that would be the formal way of saying it. I'm fine with the idea of angles overlap. We can also use this to set up and solve algebra. Here's a shock. We're using a geometric concept to set up and solve algebra problems. It says the angles basically indicated here are supplementary. And that makes sense because if BCD is a straight line, then the two angles making them up have to add up to 180. The straight line is 180 degrees. So now I have to set this up. Now, again, we have to be very careful how we set this up. We don't just want to do what we talked about a couple days ago and slap the whatever two algebra expressions we see and set them equal to each other. That's going to work about a quarter to a third of the time. The rest of the time, it's not. In this case, clearly, I have an obtuse angle and an acute angle. It would not make any sense to set them equal to each other because they're clearly not the same measurement. So I have to decide if they're not the same measurement and aren't equal to each other, what is true about them? They are supplementary. Oh, that means they add up to 180. So 4x plus 8, I said 4x, I wrote 3. Plus the x plus 2 is 180. There's my equation. And just like we did yesterday, since all these terms are on the same side, we're going to combine terms. 4x plus 1x is 5x. 8 plus 2 is 10. So I get 5x equals 170. Subtracting the 10 from each side should show my work. And then divide by 5. And x equals 34. And there's my solution. Or is it? Am I really done? No, I'm not. We get stuck on this so many times. A lot of you are getting stuck on this in the homework earlier this week, even though we talked about it. I found the value of x. That doesn't mean I'm done. This is an algebra where the problem is find the value of x and you're done. It's not the way it works anymore. Now it's saying find the measure. The question says find the measure of BCE and ECD. So we got to go back. Measure of angle BCE. BCE is 4x plus 8. So 4 times 34 is 120 plus 16, or 136 plus 8, or 144, and it's degrees. And do the same thing for ECD. ECD is x plus 2, which is 34 plus 2, or 36 degrees. And as an error check, I take a look at those numbers. 144 and 36 is added up to 180. It certainly does. I know I'm right. Everything checked out. So again, don't get caught. Oh, I solved for x. I'm done. Maybe. Maybe you're done. Maybe you're not. You have to go back, read the problem, and decide, is it asking me for more than just the value of x? If it is, you need to continue on. Like I say, that's one of the huge differences between algebra and geometry, is that these are almost all applied algebra problems, which rarely means that we can just quit at finding x. Sometimes it might say that. Here's another one. Angle LMN and PQ are complementary angles. Find the measures of the angles when LMN is 4x plus 2 and PQR is 9x plus 1. So, I don't have a picture this time. If I'm confident with my definition, I don't need to make a model of this by drawing a picture. However, some people may say, I want a picture. So you have to be careful not to assume things that aren't given. So it says they're complementary angles. Does it say they're adjacent? No, it doesn't. So I don't want to do something like this with a right angle here, because this implies a special relationship that they're actually adjacent as well. And that could lead to some problems. What I want are two angles, and I can draw them kind of by each other, but not exactly. One is 4x minus 2 degrees. The other is 9x plus 1 degrees. And I did draw them so it looks like they're going to add up to 90. And now I can set up my equation. 4x minus 2 plus 9x plus 1 equals 90. Why 90? Because complementary. Again, combining terms, I get 13x minus 1 equals 90. So 13x equals 91. Divide by 13, I get x is 7. And am I done? Nope. It says find the measure of the angles. So angle LMN is 4 times x, which we just said is 7, minus 2, which is 28 minus 2, or 26 degrees. Angle PQR is 9x. I should put the measure of. Measure of angle PQR is 9x plus 1, 63 plus 1, or 64 degrees. And now we have our solutions. So again, just be very careful. Make sure you're checking that your answers match what the question is asking. That's all we have for today, and we'll see you in class.